Hi everyone, my name is Veronica Hylák and welcome to a GenAI technical crash course courtesy of MetaLinguist. Today we're going to be covering the core concepts and basics of how generative AI works and how it fits into the AI ML landscape. My goal for you is to walk out of here and understand a lot of the major buzzwords that you probably hear all the time, but maybe don't understand how they really all connect. And although I'm consolidating a presentation that normally takes me an hour into only 14 minutes, we're at least going to open the black box for you today. Following, we're going to have a quick demo of MetaLinguist, which is a translation business management system, and how it complements you in the era of AI with practical, user-centric, and client-friendly solutions. If you are not familiar with me, a little quick introduction to my background. I have been around AI and ML technologies for a while now. I worked with top secret government programs, leveraging AI and ML for intelligence gathering systems, transitioned into the language industry through a family member when they needed a piece of software, although I could argue I've been in this industry since I was born, and ultimately co-founded a 5-minute setup, ultra-modern TBMS for LSPs, in-house teams, and freelancers. Also this year, I was voted as Taos AI Revolutionary 2023 for a new localization product I made. If you're not familiar with the Taos conference, it's a major gathering of the leading translog directors from major corporations such as Meta, Google, Microsoft, NIMSY, etc. So it's been a really action-packed year. All right, so let's get started. So as a preface, we have a broad understanding of how generative AI and foundation models work. But Google themselves will tell you there is no methodology that has been pinpointed. There's no code that has been cracked yet on how to prompt a model or optimize the LLM's performance. So if anyone acts as if they've figured it all out, unless they're better than the entire Google staff, I would run. Right now, it's all a tweak and guessing game. So ultimately, my goal with all of my projects is to improve and gain a more precise understanding from under the hood, ultimately hoping to control them better. And that's what I hope to give to you today. So I'm only going to briefly skip over this, but I wanted you all to understand how AI versus machine learning versus deep learning versus generative AI all relate to each other if you didn't already know. Artificial intelligence is the umbrella term, the discipline, and extremely generic in nature. As we drill down, different methodologies are referenced to further fine-tune an AI technology's performance. So for example, machine learning, which is the next broadest category, uses methods called supervised or unsupervised learning, which are specified on whether or not the model utilizes data labels in order to define outputs. Deep learning takes it a step further and uses everything that machine learning uses, but adds on neural networks and another process called semi-supervised learning, which is basically a combination of supervised and unsupervised that allows for more extensive data processing. And then we get to generative AI, which uses all of the above. So basically, generative AI combines and builds on all of the methods used in its previous parent categories. And what we're going to look at is really what is underneath the generative AI hood. So you might have seen this before. This is the most basic infrastructure diagram, but basically what it explains is that GenAI models take training code with labeled and unlabeled data, puts them into a foundation model, which is made of transformers, and then generates the appropriate new content. So let's dive into this a little more. The biggest component here are the foundation models. So foundation models are large pre-trained models that serve as the starting point in GenAI and captures vast amounts of general knowledge. They're trained on incredibly large data sets, which allow them to generalize across a wide range of tasks with fine-tuning. And because they can be fine-tuned or can adapt to specific applications, they're highly versatile for various industries and tasks. Some examples of foundation models that you may be aware of are ChatGPT and Bard. And if you're sitting there in your seats asking yourself, wait a minute, I've heard ChatGPT referred to as an LLM. Well, you are not incorrect, but rather it is a type of foundation model. It's specifically catered towards NLP, which is natural language processing, whereas we know generative AI can produce multiple different mediums of content, including visual and audio. To dive briefly a little more into LLMs. All LLMs can be considered foundation models, but not all foundation models are LLMs. But LLMs are specifically known for their large number of parameters, which allows them to capture the nuances and complexity of the human language. So what is a parameter and a neural network, might you ask, because they're all related. This is probably the meatiest slide that you will have to digest and probably warrant purchasing a power pack to watch at a later time, but I will do my best. Neural networks, which are pretty much this image here, they lead to higher levels of data abstraction and pattern recognition. Ultimately, they allow a computer to process more complex patterns than traditional machine learning. It's actually designed and seeks to imitate the workings of the human brain, which is pretty cool. And the fundamental component of a neural network is a neuron, also called a node. They're basically the little dots there, the blue and the green and the yellow. And neural networks receive, process, and transmit information much like neurons in our brains. The real magic starts to happen when they interconnect and start processing vast amounts of data, and they adjust their internal parameters based on the accuracy of their predictions, which is a process known as learning. Now, we just mentioned LLMs are known for their large number of parameters. So what exactly is a parameter? To tie it all together, a parameter refers to the individual weight and bias in a neural network that are adjusted and fine-tuned during the training process. So ultimately, these parameters, these little dots here, enable the model to make predictions and actually generate the text and perform other tasks by determining the strength and direction one has over another. But it's not a predefined weight, like a pound of butter. Nodes also have something known as a bias, which is actually a really good thing in this case. It's more a flexible value, and it shifts up and down according to a use case. So it makes it a lot more flexible under real world scenarios for a certain node or neuron to beat out another. To visualize a parameter in simpler terms, imagine trying to predict the outcome of a game based on multiple factors like player statistics or weather or recent performance. Each of these factors have a weight or importance attached to it, and adjusting these weights, which is akin to parameters in a model, helps in improving the accuracy of the prediction. In LLMs, this concept is just extrapolated to a vast scale, with billions of weights being adjusted to predict or generate textual content. Whew, that was a lot. Now to even more fun. The power behind generative AI is really through the use of transformers. They started to come around 2018, originally actually just for translation. And this portion of my presentation is really starts to focus on the translation performance aspect of LLMs. But it's naturally expanded, and all of the LLM that you are familiar with, such as ChatGPT and Bard, are based on models that utilize transformers. For example, fun fact, GPT stands for, drumroll please, Generative Pre-trained Transformer. Transformers are the building block for foundation models. And I'm going to skip a lot of the technical jargon here for the sake of time. But what is important about transformers is they were specifically designed for parallel processing. So while traditional machine learning, for example, was sequential, and you could only really add on to the end like a train caboose, transformers allow for the ability to efficiently train data models in parallel. So they were pivotal in creating the ability to train vast data sets. And one more important thing that they did in regards to translation, it gave contextual awareness to a text. So to truly understand the impact of transformers, the sequence-to-sequence protocol that was utilized before its birth was called RNN, also known as recurrent network. So RNNs were primarily actually also used for translation and NLP purposes, but basically the way it would work is if you wanted to translate something from English to French, RNN would take an English sentence and process the words one at a time and sequentially spit out their French content. So the key word here is sequential. In language, the order matters, and you can't just shuffle them around looking at them one by one. So, as you all know, Ronald went looking for trouble means something very different than trouble went looking for Ronald. And in an RNN, this is a type of issue that was frequently encountered. So basically, any language model that deals with language has to capture the word order, and the transformer solved that. There are three main components of transformers. The first is positional encodings. So since we just talked about the problem with RNNs where it would go word by word and cause many issues in the NLP realm, transformers utilize something known as positional encodings. Basically, it's the idea that looking at words sequentially, you take each word in a sentence, and before feeding it into the neural network, you assign a number to it, and depending on what number the word is in your sentence, ultimately, it's stored data about the word order in the data itself. And then as it's trained, it looked to interpret those positional encodings, which is awesome. The second is attention, which is a mechanism in a neural network that allows the text model to look at every single word in the original sentence in order to make a decision on how to translate and place the word on an output sentence. And the last one, which is self-attention, this was the true innovation here of transformers, because even though transformers were primarily created for translation, what if you're trying to understand the underlying meaning in language so that you can build a network that can do any number of language tasks? And self-attention created the ability for the machine to interpret the intent and gave it that level of awareness. So, for example, before self-attention, the system would really struggle to understand the difference between server, can I have the check, and looks like I just crashed the server, which is really, really different. And there you have it. You now understand the different building blocks of generative AI, foundation models, LLMs, transformers, and how they work, the concept of neural networks, parameters, and self-attention, and how their performance is enhanced with fine-tuning. But after I always tell people all of that information, I have two questions that I often still get that I hope to clarify for you today. What exactly is fine-tuning? How can I do it? And how can I build my own LLM or transformer? Is it just for the coders? First, with the fine-tuning, the most common method people refer to fine-tuning as is honestly just giving contextual awareness to the foundation model through something like a chat interface. It's just a fancy word for that. Now, you can get pretty creative with this. One of my biggest context prompts to encourage better fine-tuning of a chat thread response was about 3 to 4 paragraphs. So you have a lot of room to play with this for free. Now, the tech companies, including myself, there are many more advanced ways to fine-tune that does require coding in order to ground the model. And that often uses vector databases, embeddings, and RAG, which is retrieval augmented generation. And it almost sits as a middle layer between the LLM, which is the knowledge hub, your encyclopedia of all your information, and the final user. So basically, they have a grounding model that kind of sits in between. But let the tech companies do that for you. As I said, they're kind of still figuring it out. The second is, how can I build my own LLM and transformer? The answer is you really can't unless you have $100+ million and probably arguably even more. And it wouldn't be the best use of your resources anyway. You really should be leveraging the LLMs that already exist, and you can't really pick a transformer out of that. It's already kind of baked in. I do have one loophole for that as I close this presentation. Just on Monday, OpenAI announced that you will be able to make your own GPTs through their chat interface with no coding required. This means that you can almost have your own personal instance of their LLM that you can better fine-tune for your needs without any coding. It's not released yet, but it is coming in the coming weeks.
Hello, my name is Bridget Hylák, industry strategist and consultant on the MetaLinguist system, as well as a certified translator and court interpreter, trainer, author, and a lifelong industry fanatic. I consult with clients worldwide on language technologies, DEI, and accessibility. That lovely lady you just saw is my daughter, Veronica, who arguably has been involved in this industry since birth, since we love to talk about our industry. And she has a breadth of experience and expertise in software design, management, and beyond. We represent two ends of the industry. I'm looking behind me at decades of growth and innovation, and she's recently taken on a more visible role industry-wide. But we both share a common goal, doing all that we can to move the industry forward, to keep cash flow and opportunities in the hands of linguists and LSPs who really want this. And that was the impetus behind building the MetaLinguist translation business management system. Veronica's about to give you a demo of the system, but By way of background, as a business owner for decades prior to my current consulting duties, my colleagues and I struggled with project intake. We've all been there. Endless email threads, Dropbox messages, portals that are outdated and ugly that clients just don't want to use. And who could blame them, because they take longer than email. And in general, translation business management protocols that were either disjointed, clunky, or simply frustrating. We have heard the pain points, and indeed, my fellow consultants and I on this project are all industry veterans who know how to sell language. Metalinguist was created to solve these problems, to keep dedicated language professionals in the game, and really to make a fun, painless experience for clients and language business owners who may struggle with tech and just want to get out of the gate quickly. Please know that half of the goal of this system was to provide an updated, quick, and shiny UX that your clients just can't resist. And we have seen the stats. It's doing its job. So with that, I hope you enjoy this quick demo, and I'll be back right after.
Metalinguist is a translation business management system with everything you need to manage clients and curate their experience with your business, all under one roof. It's an end-to-end client solution with everything from project management and submission, quotes, invoicing and payment processing, accounts, white labeling, notifications, and more. We're ultra modern and intuitive with no onboarding time. We even had Apple designers consult to make an interface that thinks like you do so that you're an expert from the very first click. And our users have told us that they have seen a 4 times increase of direct contacts. What can we say? Word gets around when you offer clients a modern, simple way to transact with your business. Our onboarding process is 3 simple steps, asking you for your core information, you to select your source and target languages for your company, as well as select your theme, which you can change at any time. And you're already done. Automatically, we start to curate your website and launch it at your new own URL. This is your view as an administrator. You have various reports that you can interact with, including top orders by target language, performance, such as total orders, total quotes, and total invoices over a period of time, your top customers in terms of sales and orders, and more. You can switch to dark mode when your eyes get tired in the late night, see in-app notifications, as well as interact with our Knowledge Nook, which is a hub of information to interact with our website and translation industry terminology. Orders are a breeze with Metalinguist and the source of truth, as well as a digital filing system. From everything from the order information, update history, reference and source files, and target deliverables, you and your clients have everything you need to know about an order and its progress, being notified every step of the way. You also can do quotes, manage accounts, see individual profiles and fill in their information, quickly reset their password, and see their billing information. You even can do invoicing through us. Here's the fun part of our system, our simulation experience. A big part of Apple design is a concept called WYSIWYG. What you see is what you get. These are live components within the system so that you know exactly what your system is going to look like before you apply any changes to it. We have 24 modern themes for you to choose to match your business's aesthetic. Here is an example of how you can white label your system. Also utilizing WYSIWYG, we walk you through the live component and show your changes as you make them without affecting the live system. And lastly, you can even edit email templates and more. Want to know what your client's experience is going to look like? Pure bliss, if you ask me. They can quickly view projects, request quotes, pay invoices, and request new orders, all within one place. Metalinguist helps all kinds of language industry professionals by creating a digital storefront for their company and empowering them to organize and simplify all aspects of running a leading language business. Some news on our front, Metalinguist and Trados are launching a 2-click, 1-minute integration and data import next week. And as a final thank you for attending this summit, we are offering a free 2-month subscription to all AI and Translation Summit attendees. You must submit a registration request on our website by November 25th, and we will get back to you within a week with your onboarding link.
Wasn't that cool and simple and easy and fun? That's the whole point of this system. We hope that you enjoyed the demo. If you're interested or have any questions or feature requests, please reach out to us at metalinguist.com, and let's keep this industry in our hands. It's ours. Have a great afternoon, evening, or morning, depending on where you're at. Bye-bye.